Just as a matter of course, we've got about 10 minutes for our discussion. We don't want to hold anyone up for heading upstairs. We've only got an hour and a half up there. But by all means, you gentlemen going to be hanging around upstairs for a little bit?
Yeah.
Excellent. So any questions that we don't get to now, we can go upstairs. A couple of quick ones, and then we'll open it up to the floor. Mike, why is it that mainland Europe is ahead of the UK?
Probably vision and funding. I think are the two answers there. And if you look at the respective hydrogen strategies of the various countries, you will see the number of zeros that make up the difference. I think from the rail point of view, there have been different approaches taken by different countries, and hence we've got different products in each country, but there's also compatibility issues around that. But all of them have included a degree of public sector encouragement, shall I put it like that, which whilst you get a pat on the back here, it's what else can we do, and where's the vision? And the rail sector at the moment is in a phase of reorganisation, which hopefully will yield that vision. As I said, there was one, it's being reworked, but a 30-year strategy is only going to last 2 years, we're going to say, we're never going to get there. So that's really it.
Matt, can you add anything to that?
Absolutely echo commitment, scale and vision. Not on that continent, but we're just looking at a switcher project in 632 freight locos in the UK. There's 38,000 in the North American market. The noughts in the funding, the noughts are just in the wrong place. Yeah.
Okay, thanks. In terms of how much of the network you decarbonise through hydrogen, it seems some original numbers somewhere down about 8 or 9%. What are Elston's figures? I know you put up a map.
Yeah, that map was actually the Network Rail map. So Network Rail, of course, is the infrastructure owner. So if you ask the infrastructure owner to come up with the solution to decarbonising the network, fundamentally they go with an infrastructure solution, which is electrification. That did set the percentages of something like that, 9 or 10% for hydrogen. I think realistically, we never envisaged to get that much electrification anyway. You're talking 2-3 times that probably. But it's not, like I said, it's very much about where it suits rather than pushing hydrogen at the expense of anything else. That's not the point, but that's going to be the amount. We've got 38% of the network electrified at the moment. The rest is operated by diesel. But 75% of journeys take place on the electrified routes. So we've got capacity, we've got growth opportunity on those other routes. But they tend to be regional, they tend to be between smaller cities feeding into the main core. And that logically suits hydrogen, especially if we can come up with that coordinated railway where you get off one train onto the next one in confidence rather than a panic.
Absolutely. Yeah, no, where appropriate. We've all agreed electrification is great. You're going to take the electricity there, but there are times when you sit in electrolysis. With the efficiencies of fuel cells and our system, the difference is you can harvest the curtailed wind when the trains are running, and that difference is more than the extra electricity that you're putting in. From a steamology point of view, the low-hanging fruit is repowering existing assets, and those DMUs, there's thousands of them, they're mechanical, there's no money in the industry, you can get another 20 or 30 years, we're still buying new ones, there's plenty around that have got 20, 30 years on them. So if we do go down a hydrogen route, refuel those, keep those going as a low-cost route, and in the future, with the new build OEM, they've got to be hybrid. So use the wires wherever possible, and then use these as just before then.
It's probably worth saying that investigative work is also going on into hydrogen ICE and conversion of the engines on those existing trains. It has to be said there's wide gaps in the generations of hydrogen trains in this, diesel trains in this country. So there are some very old ones, and then there was quite a gap because the government plan was to electrify. I don't know if you remember that, they got cancelled and some more got bought. Now no one will fund them because the writing's on the wall for diesel, so you're going to struggle to get brand new ones now. But some of them are just being delivered.
Yeah, and there's a difference between zero emission and zero CO2. But yeah, and also it's that bit. So both hydrogen in ICE and the Steamology system can use blue and grey hydrogen, which gives you more access to cheaper hydrogen now, which is great. But at that 300 kilowatts, and certainly once you get into the freight, we think we have a place to play at zero emission. But absolutely, that reworking and the overall drivetrain efficiency. But yeah.
Yeah, freight is seen as the real big challenge. So
Yeah,
if you
yeah.
get a provider solution for freight, that's
Yeah.
Can you explain that in terms of the frame, in terms of the magnitude of why the freight is the...
well, I guess if you have imagine a 4-carriage regional train, the total installed power on that would perhaps be 1 or 1.2 megawatts. One of those Class 66s we just saw was 2.4 megawatts, and an electric freight locomotive would be 5 megawatts. So, and all very warm, capable of it. But that's the kind of order of magnitude that you're talking. So, hydrogen sits well because the energy, the energy density of the stored energy on board. To generate those levels of power, you're going to use so much of that energy. You've got no range. So. That's where, if there are solutions that can carry enough fuel and deliver the range, that's great.
From our point of view, the interest and the adoption both in aviation and maritime, and the scale of that, if that direction travel towards the sectors of liquid hydrogen and the infrastructure, you're then another times 4 on energy density. So, and working with people like Chart and such like in the States, they're all already going that way, and it's being accepted and being the norm. So then the numbers can start to work again, and you've got no electrification on that side of the problem.
Excellent. You just touched upon there about the multimodal infrastructure opportunity. So is that something that could help unlock or expand?
We're really keen on that, particularly at this early start of the cost. The major cost in any project for us is the fueling station. If we can share it, we can do a train thing. So the point was made earlier, port for us is fantastic. We've got freight trains, we've got passenger trains, we've got maritime, we've got heavy lifting, diesel equipment, we've got everything. So those are the places where we'd like to deploy this, because suddenly everything's common.
And of course, a lot of ports export their materials across land by rail, so you can use trains as well.
Last good question here. Talk about how do we develop supply chains to roll out these hydrogen fueled trains?
Build some. If we actually build some trains, we have a demand. You see a lot of initiatives, innovation initiatives and all sorts of things in the market about creating a supply chain driven from the bottom up, funded by funding schemes and other things. But if there's no top-down demand for what you create, ultimately when the funding ends, so is your business. So you need to be building the trains, building the products, any sort of hydrogen product. If we create enough demand for fuel cells in this country, the fuel cell supply sector will thrive. But if we don't have a demand here, it will probably end up getting set up wherever that demand exists and then exporting to us.
Yeah, I mean, we're at the heart of Steamology is a cradle-to-cradle ethos. That's genuinely respecting the circular economy, and so it's about the area under the graph, right? So we have to move fast, we have to use existing things. So we don't need, the comment was made earlier, how much has gone into British Volt. You can make a Steamology turbine, like we make our own on our own CNC machine. We can make them, anyone can make them. So all of the stuff that we make is with the same materials that a diesel engine industry at $207 billion a year is currently making. That diesel engine industry is all changing in the next 10 years. So we can move not using lithiums and cadmiums, etc. We can move using mechanical skills. The capital means of production exists to churn this stuff out. It's licensed out of the CAD farm. So we can move fast. So make it with a clean cradle-to-cradle circular economy intent, and we start using stranded assets, but then move on to brighter future. Yeah.
New type of legacy.
Yes.
Nice plug. I think looking at time, we've probably got time for one question from the audience. I think someone down the back had a question.
Yeah, sorry, it's Alex. I work for Digital Training Company. It's a bit of a specific question. If you were to choose one part of that map, where do you think you'd be able to more readily deploy, a hydrogen solution, a hydrogen train? Where would it be around the country? What train?
So, at the moment, probably first likely deployment is going to be in Scotland. Surprise, surprise. Beyond the remit of DfT, Transport Scotland and the Scottish Government are pushing very hard towards hydrogen production and use. That kind of environment, coupled with copious amounts of renewable energy, is the ideal scoping around side, but probably expected to be there first. Tees Valley was leading, but it's kind of dropped back a little bit since.
Yeah, I'd agree. Yeah.
One more down the back.
Yes, David Bernard from Air Liquide. We'd like to know from Alstom what is the relationship you have with your colleagues in France and in Germany, where some trains already have been tested and after here, some area in Europe, continental Europe.
What our relationship is with them. So, Alstom is a global company, and we use a sort of global production footprint. So, that's built around standard bricks of production, as we call them. So, a fuel cell module is a brick, a battery is a brick, in effect. It's not quite Lego, it's a bit more complicated than that, but what that means is the train I showed on the screen, the UK train, is based around very common technology with what we have in Europe. The issue with UK railways are that the size of the trains is much smaller in cross-sectional area, because that's dictated by the tunnels that Victorians built, in simple terms, because trains are smaller back then. And the vast majority of our infrastructure is very space constrained, and small tunnels, platforms close to the train. In Europe, they're bigger. So we have to repackage that technology and perhaps get a little cleverer around how we fit it all in, especially tanks, because there's very little space for storage. So you can imagine we learn a lot, we talk a lot, we communicate very frequently with each other, but each market does have its own constraints.
Thank you for your question. And at that point, we will wrap it up. Thank you very much to Matt and Byron.